Hey everyone, it's Jim
and Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 229, we're going to talk about rectifiers, part 2. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Well, before we get started with today's episode, I thought it would be fun to drop in on the first review of the new modern line kit phono preamp. Well, that was a mouthful. Currently, the test builders are starting to finish their kits, and every day we're getting updates. This is both a lot of fun and also a time for tight butt cheeks as we watch for any issues that might come up. And that, of course, is the whole point of shipping kits to test builders. Test builders always make significant contributions to each kit that they work on. Now, they might look like little tiny things, a bit of improvement here and a bit of an improvement there, but altogether they add up to significant improvements over a long period of time. Because
and not just for that one kit too. They inform on everything we do afterwards.
Right. So every kit that's ever had a test builder always improves kits down the line, sometimes many years later. Okay, now the review is really long, so let's just drop in on a couple of key passages that I've highlighted. And if you're interested in reading the whole review, it's an excellent review. I'll put a link below. Okay, so what did Gary say first? Their design just seems to get out of the way and let the tubes do their job and amplify the signal. It's as simple as that, and I, for one, think that's the way it should be. Yeah.
We do too.
Yeah, that's an excellent interpretation of what a quality amplifier does. Short and sweet and to the point. I like it. Okay, what's next? I'm getting so much more out of my music. It feels like the music has more layers. The instruments that I either barely noticed before or never noticed at all had their own space to be heard. Okay, so what he's talking about there is higher resolution. And higher resolution means lower distortion has to be in the signal path, and high quality amplification. So a lot of what makes our phono preamp sound so good is the 6SL7 tube. It is an amazing high gain tube. Is it the highest high gain tube out there commonly in use?
Of course not.
No, absolutely not. But is it the best overall tube for a phono application?
Oh, we think so.
Yeah. Okay, last little note. The sound is tangible. That is the best word to describe it. There were times when I was listening to the music that I felt I could reach out and grab the instruments around me. Yeah, that's the sort of review that engineers, designers, kit sellers just...
This is what we want to hear. I mean, this is what we hear from our own system, and we love to share it, and we love to listen to other people experience it as well.
Yeah, I don't know if everybody realizes this, Charles, but we're audiophiles first.
Yep.
I mean, yeah, we own a vintage tube business, and we own a kit amp business.
But we want to listen to great music.
So the impetus that got the kit business going was my desire to improve the sound of my system. I was just so disgusted with commercial products. They make so many compromises. And most of those compromises have nothing to do with, the overall look of the product or maybe not even the marketability of the product. It's just got to do with dollars and cents,
Yeah.
A good quality design costs a lot of money engineering-wise because you have to put a lot of time into it. And a good sounding audio product costs money to build because good quality components cost money. So,
but that doesn't mean that it has to be overly complex or have a bunch of features that are essentially unnecessary.
No, but the interesting thing is that a good, simple design actually takes a long time to design.
Yeah.
That's the crazy thing. Anyways, there will be more reviews, and we'll probably do a big episode over on the Mellatone Amps channel, talking about the reviews, the insights, any of the little quirks that people found while they were building. But Charles has got a really exciting episode planned in which we're going to have. Are we going to have lightning bolts?
We're going to try to. So let's clear the deck here, and I'll get the new tester set up, and we'll take a look.
Okay, wow, that's quite a contraption you've got there, Charles.
Yeah, well, it started off just as a prototyping board sitting over on one of our workbenches, and, we were just going to do a demonstration this week for you, but we've realized, hey, it's basically a rectifier tester already. Why not put it into a proper chassis? And it's actually really simple on the inside too. So here's the schematic for it, and it's based mostly, I don't know if we can get that really clearly in focus here for you guys. Let's see if I can switch the focus. Aha, there we go. Okay, so it's based loosely on the RCA receiving tube manual schematic for how to set up a full wave rectifier. And this is a way of getting full wave rectification with two diodes, because these rectifiers have two sections in them, two internal diodes. You can actually replicate that these days with solid state diodes in a very similar configuration, as long as you have a center tapped transformer. But one thing this does need that solid state diodes don't is a heater tap for them. So this is a 5-volt tap to power the heaters on most standard vintage rectifiers like the 5AR4 or 5U4G.
Which, of course, we wouldn't need if we were running solid state.
Mm-hmm. And otherwise, there isn't a whole lot on the schematic. We went over sort of the beginning area here of the transformer and stuff last week. We have our tube here. We have a first stage filter cap that is selectable. And this doesn't matter too much for testing, but it's great for demonstration purposes.
And how are you loading this down? Because, obviously we don't want to drop this circuit into, an amp. We want to create some kind of a dummy load that's safe.
Yeah, and we have a great dummy load. So we have these decade boxes that are vintage. They're using these huge power resistors. Actually, I think you've got some right here.
Yeah, I pulled some that are extra because we modified one of ours. And so there's big banks of these in each one of the decade boxes. In fact, one of our decade boxes, a lot of them have the company logo
still on them, yeah,
literally riveted onto the chassis, and we've got one that was in the General Electric lab.
Yeah, isn't that neat?
Yeah.
Actually, we've got a GE data sheet. We're going to take a look at it in a minute too. So we've got our load over here, and we have a way of measuring our current, and that's just by measuring millivolts across this 1 ohm resistor here that we selected. And that whenever you're measuring voltage across a 1 ohm resistor, you can convert it right over into milliamps. So every millivolt, 1 milliamp. So this whole system allows us to do a few things. It allows us to select our capacitance.
So that would be the first cap in the filter stage, typically in a power supply.
Yep, which can be really important for rectifiers. It can allow us to change our loading, which is also very important for the tubes, because that's going to affect the total current and voltage that are being output. And it also has, it also has switches for bringing in each section, so we can actually switch it between full wave and half wave rectification, which is also cool for demonstration.
I think you're going to show that, aren't you?
Yep. And it has multiple sockets. So we have a 4-pin socket, a 9-pin that you can't quite see behind the 5U3C here. We have 2 octal sockets, and these are actually wired up almost the same. I'll get to that in a second. There's actually one last thing I should show you on here that's really important, and that's these 5-watt 100R resistors on the transformer secondary. And you might be wondering, what in the world are those doing there?
Well, they're easy, right? Just think of them as electrical shock absorbers.
Yeah, that's basically what they are. And this is not something that you see on every rectifier datasheet out there, and you certainly don't see this on a lot of amplifier schematics. But rectifiers have a spec for the secondary windings resistance. It needs a certain amount of resistance in relation to the voltage and current that is going to be flowing through that rectifier, or there's going to be a huge inrush current and possibly an arc.
That's what leads to lightning bolts.
So if you don't see these, and if the transformer wasn't properly spec'd, well, you're going to have a higher chance of arcing. All right, let's take a look at the GE datasheet, or at least part of it here. This is for the 5AR4, or GZ34 as it's often known, and they were nice enough to put this really neat rating chart here. And what it does is it shows you the relationship between that plate supply resistance per plate and the plate supply voltage per plate here, and how if you have a certain amount of voltage being supplied, you have to make sure you have a certain amount of resistance.
So as the voltage of the B plus goes up,
the resistance required goes up as well.
Okay.
And this is something that is often omitted, forgotten about, not known about in modern design, and it can lead to a lot of extra wear on your rectifiers, and also sometimes it's intentionally left out because by putting those resistors in, or by having a secondary tap with higher resistance, we drop our B+. And if you drop your B+, you lose a little bit of power output and you don't quite get everything out of it that you can. But it does protect your rectifier.
yeah. And often on forums that are talking about problems with vintage rectification, you'll see posts, how come my amp is eating rectifiers on a regular basis? Well, that's probably why.
Yep. Okay, so we've got a neat demonstration set up here. We're going to get the lights off and we'll see you back here in a second. Okay, so we've got our 5U3C or 5U4G made by Svetlana here, nice and preheated. Over here at the bottom we have a millivolt meter set up, and this is measuring our milliamps. It's a direct conversion. And over here we have our DC voltage that's being measured on the output. We also have a scope hooked up, and we'll go into that a little bit more in a second here. But what I wanted to show you is what happens to one of these tubes whenever you don't have it set up correctly. So on this other octal socket, we have omitted those two 100R damping resistors on the secondary. We've given it a really large input filter capacitor of 390 microfarads, way above the spec, and we've increased the load. So watch what happens whenever we turn on the high voltage supply. Pay attention right here.
Whoa! Lightning bolt!
Yep, so that's what happens. You get an arc. So let's switch that off. And now let's set up the tube to run like it's supposed to. We're going to take it out of this socket, move it over to one with proper damping, and we're going to turn down our decade box to the correct loading for the tube, and the correct capacitor
is a 47 microfarad, and that comes from the data sheet, right?
Right.
So that's the maximum first cap that's allowed?
It can
Or is
actually
it
be a little bit higher, but the standards have changed over time, and this is a common standard these days, so it's a good first option for it. And now we're going to do the same thing. We're going to bring the high voltage back in and see if we get an arc.
No lightning bolt that I could see.
No lightning bolt, because now the tube is being operated the way it wants to be.
Well, the way it was designed to be.
Now we can actually take a look at this sine wave. It's kind of hard to see because it's really washed out on screen here. But
that does not look very DC-like, does it?
No, and you might not be able to read it, but we actually have 20 volts peak to peak in this sine wave that is sitting on top of our 392 volts of DC. So this is the ripple that's still present without extra filtering.
And that's because there really, other than one cap in the C1 slot, there really is no serious filtering.
No. And we have 120 hertz because we have the 60 hertz frequency being doubled up because we have the full wave rectification.
So what happens if we take out one section?
Well, watch what happens here.
So we lose half of
the frequency
and half our power, basically. And the power that we lose is 180 degrees out, right?
Of phase, yeah. And you can also see that our filtering has now gotten considerably worse. We actually have 40 volts peak to peak of ripple sitting on top of it right now.
Let's put it back so people can watch what happens. So we've only got 1/2 of a twin diode rectifier operating, and now we've got a second half engaged. So you see how, even though it doesn't look like it's a lot smoother, in fact, it's essentially twice as smooth.
Yep.
So it still needs a lot of filtering.
Yeah, so what happens if we drop the filter capacitor on it? Well, look at that big of a difference. And this is the reason why builders will put in a much larger cap on here. I'm not going to bring it over to the 390 because it might actually arc it right now since it's completely empty. But you can see the difference right away from a 10 to a 47 microfarad capacitor. So this really drives home the importance of properly setting up your circuit for your tube, for the tube that's going to be in there. And this is the main reason why there are a lot of arcing vintage rectifiers out there.
So does it have anything to do with the actual rectifier tubes?
No, it's because the circuits were set up for modern production versions of those tubes that really aren't the same tube anymore. They have a different spec. They don't arc in the same operating conditions because they weren't spec'd the same.
They weren't built to the original specifications.
Right.
They're built to some modern spec that is in many cases not even published, because a lot of modern tube manufacturers actually copy data sheets
and just post it up as if that's what it is, but clearly they react very differently.
Okay, so moving forward, this is going to really improve our testing of rectifier tubes, isn't it?
Yeah, well, we have a bunch of vintage testers that, don't get me wrong, they're fantastic, but they don't give us proper milliamp testing numbers or allow us to test the individual sections, get milliamp testing numbers. And it's a common issue with testers, even for power tubes. They don't run the tubes at the same operating point they would be used in circuit, and this is going to allow us to do that.
I don't think I've ever seen a rectifier power tube or power section, or I don't even know how to describe that, a properly designed and built commercial rectifier tester.
Yeah, well, there aren't a lot of them used anymore except for in hi-fi amplifiers and guitar amps out there, and most vintage testers have a section for them, so people just go with that. We did until this, but I think this is going to be a better option for us.
Okay, well, thanks a lot for doing this, Charles. And I think probably in a future episode we'll do some more demonstrations, but I think it's time to take a break from rectifiers.
Yeah, well, maybe. Let's go take a look at what we had come in.
Okay, well, what came in, Charles?
Well, a bunch of rectifiers. No wonder we were talking about them.
And in fact, we actually even have some more coming in. And for the first number of years of the business, even though I had a lot of rectifiers, we really didn't have much demand. But in the last year and a half, 2 years, we've been getting more and more demand for 5U4s and for...
especially 5AR4s.
5AR4s. And talking 5AR4s, you've got a lovely one right up at the beginning.
Yeah, we've got 3 different versions here, starting with the lovely Matsushita 5AR4. These were made in Japan and on late Muller tooling, and as you can see, they are testing extremely high. 100 is center for new old stock, so these are roughly 20% over. And these are just fantastic tubes. They have very dark chrome on them, which implies that they have extremely strong vacuums in them, and they all test excellent.
Yeah, and these are probably late production. What's with the National box? Oh, is that the brand name for Matsushita?
It is. So as you can see right here, we have National Matsushita. And this was their sort of domestic home brand, and not to be confused with National Union, which also tended to have red text as well. Different companies, different tubes. They tended to be a rebrander for everybody.
Not Matsushita. They made their own product. What's next?
We have the Toshiba 5AR4. And these are also excellent tubes. They're great testing, although they tend to test lower and on spec than the Matsushitas do. But they're very reliable and they're excellent. They weren't made on Muller tooling, of course, like the Matsushitas were. But these are what I would consider to be an excellent mid-range vintage 5AR4. And lastly, we have something that's new to us, and probably new to you guys as well. This isn't a 5AR4. This is a 5G K20. Take a look at that right there. And this is NEC's version of the 5AR4. It's entirely compatible in specs and in pins, and it has a very different plate design to it, which is really quite interesting.
Yeah, in fact, a lot of rectifiers, even of the same type, will have unique plate designs as manufacturers try and come up with ways to dissipate heat as efficiently as possible.
Yeah, and you can see these guys are also very high testing, and they come in these beautiful NEC boxes. We've been getting more into NEC tubes lately. They have a very interesting company history. Their actual tube factory was originally set up by Western Electric in Japan, which is exciting just on its own.
Ooh.
And you can see these were labeled the Hi-Fi Green series, and they are great testing tubes. We've got some more of them in, and we're looking forward to getting them into your guys' hands.
Okay, and we're going to start a new program because a lot of people are finding times to be really tough right now. So most weeks, if we have a surplus of a certain type of vintage tube, we're going to put a 1-week sale on it. Just because we've got lots of them, we can give everybody a break for a week. And please don't send me an email like 3 months from now and say, is that sale still good? No. So what are we going to do first, Charles?
Well, we're going to do the Matsushitas. We got in some beautiful new old stock ones, and yeah, we're hoping to move some out to you guys.
So there's a sale price in the store, which you'll see if you scroll down once you get to the item. And you can go ahead and double dip, which we normally don't allow, but this time we will, so you can actually use a Cheers code on top of your sale price. Fun, eh? And talking about Cheers codes, if you stayed to the very end, here's some codes to help you out. There's a code that quite a few people get that costs us a lot of money. It's really easy to figure out. And we can reach pretty much everyone around the world with $20 flat shipping. But if your order is $150 or more after discount, the shipping's on us, folks. This is Jim.
And Charles.
Signing off. Cheers, everyone.